Lunar congestion. The growing risk of collisions in space. The renewed global interest in lunar missions is rapidly escalating, bringing with it a critical challenge: avoiding collisions in the increasingly crowded space around the Moon. While the vastness of cislunar space, the region between Earth and the Moon, might suggest ample room, the reality is that concentrated orbital patterns and limited tracking capabilities pose a significant and growing threat. The illusion of cislunar space is enormous, roughly 2,000 times larger than Earth's orbital area. However, spacecraft don't distribute randomly. Missions tend to converge on stable, desirable orbits around the Moon, creating localized congestion. This means that even with vast distances, the probability of intersecting trajectories increases sharply. The problem is compounded by the limitations of current tracking systems. Existing sensors struggle to consistently monitor objects so far from Earth, partly due to interference from the Moon itself. This uncertainty forces operators to take evasive maneuvers even when the actual collision risk is low, wasting fuel and disrupting mission objectives. Simulation findings. Collision risk is rising faster than expected. New research published in the Journal of Spacecraft and Rockets demonstrates that the collision risk is accelerating faster than previously assumed. Simulations show that even with only 50 satellites in lunar orbit, each spacecraft would need to perform, on average, 4 collision avoidance maneuvers per year. Given current growth rates, this level of congestion could be reached within a decade. Real-world data supports these findings. India's space agency reported that its Chandrayaan-2 spacecraft required 3 evasive maneuvers in just 4 years, despite only 6 spacecraft being in orbit at the time. National security implications. The lack of reliable monitoring in cislunar space isn't just a safety concern. It's also a national security vulnerability. The ability to conceal weapons in this region raises concerns about the potential for undetected hostile activity. The U.S. Space Force is actively evaluating these risks, recognizing the need for improved cislunar space domain awareness. Solutions in development efforts to address this growing crisis are underway. The Air Force Research Laboratory is funding the Oracle program, which aims to deploy a satellite at a Lagrange point, a stable orbital position, to enhance monitoring capabilities. The first Oracle satellite is slated for launch in 2027. However, improved monitoring alone isn't enough. Effective coordination between space agencies and commercial operators is essential. NASA is leading efforts to track and assess lunar traffic, comparing operators' data to identify potential close approaches. The need for international cooperation. The Outer Space Treaty mandates that countries avoid harmful interference with each other's space activities, but it lacks specific guidelines for coordination. The United Nations Committee on the Peaceful Uses of Outer Space has formed a team to address these gaps. With increasing government and commercial missions planned, including NASA's upcoming human lunar mission in 2026, international cooperation is paramount. The future of lunar exploration depends on proactive coordination to ensure the safety and sustainability of space activities. In conclusion, the rapid increase in lunar missions presents a growing collision risk. Improved monitoring, combined with international cooperation and proactive coordination, is essential to mitigate this threat and secure the future of lunar exploration.